Hey everyone, welcome back to Raspberry Pi Made Easy. In this video, we're diving into a hands-on project that's both fun and practical, connecting a 16:2 LCD display to your Raspberry Pi. By the end, you'll be able to display custom messages on your screen, making your Raspberry Pi projects even more interactive. Let's jump right into it. Before we start, here's what you will need for this project: a Raspberry Pi 5, a 16:2 LCD display, some jumper wires, and a 1 kilo ohm resistor. A quick background about the 16:2 LCD. This is one of the most widely used displays in DIY projects. It can display 16 characters per line and has 2 lines, making it perfect for simple text outputs. Whether you're displaying system information or outputs from your projects, it uses a controller which is easily controlled through the Raspberry Pi GPIO pin. Let's now start connecting the hardware connections. First, connect the power and ground pin from your Raspberry Pi to the breadboard. Then let's connect the LCD display to the Raspberry Pi, and here's how I've set up the wiring. For K, which is the backlight cathode, connected to ground. For A, which is the backlight anode, connected to your 5 volt. For D7 to D4, which are the data pins, connect D7 to GPIO pin 14, connect D6 to GPIO pin 15, and connect D5 to GPIO 18, and lastly connect D4 to GPIO 23 on the Raspberry Pi. Then connect the VSS, which is ground, to the ground pin on the Raspberry Pi, followed by connecting VDD, which is the 5 volt of your LCD, to the 5 volt power pin on your Raspberry Pi. V0, which is for contrast, we'll adjust the contrast by connecting this to a ground by first plugging in the 1 kilo ohm resistor and establishing this connection. The enable pin, connect that to GPIO 24. The RW, which stands for read and write, connect to ground. And finally, the register select, or the RS, connect this one to GPIO pin 25. Now that's everything wired up. Let's move on the code. Open your Python editor and follow along with this code, which can be found from the description. Once you run the code, it should display Raspberry Pi 5 on the first line and 16:2 LCD display on the second line of the LCD. Here's a high-level explanation of the code for controlling the 16:2 LCD display with the Raspberry Pi 5 using the GPIO 0 library. The GPIO pins setup portion initializes the specific GPIO pins on the Raspberry Pi. These pins are used to send commands and data to the LCD. In this case, we control the register select, enable, and data lines to operate the LCD in 4-bit mode, which reduces the number of pins required. The LCD init function sets up the LCD for operation. It sends a sequence of commands to the LCD to initialize it, configure the display for a 2-line mode, turn off the cursor, and clear the display. The LCD byte function sends data to the LCD. The LCD communicates via commands and data. The LCD byte function sends either commands or data by toggling between high and low beat. After sending bits to the LCD, this function toggles the enable pin to let the LCD know that the data is ready to be read. The timing is crucial for ensuring the LCD processes the data correctly. The LED string function takes a string and displays it on one of the 2 lines of the LCD. The main program loop section continuously writes 2 lines of text Raspberry Pi 5 on line 1 and 16:2 LCD display on line 2 to the LCD with a 3-second pause between updates. If you found this tutorial helpful, please give it a thumbs up, subscribe, and leave a comment if you have any questions or suggestions for future videos. Thanks for watching Raspberry Pi Made Easy. Keep experimenting, and I'll see you in the next video.